All right, so this is a video on how to solve word problems. So word problems associated with solving a system of linear equations. This is the same example we did the other day in class, but I just wanted to create a video of it so it gave you the opportunity to rewatch it and just so you can understand the process of how to solve these types of word problems. So if we look at this question, we have that there are no equations, right? So the only difference between the word problems and the problems that we were looking at up to this point was that you actually have to set the question up. So you have to determine what those equations are from a situation that's given to you in words or in paragraph form. So let's read the question. We have Christian has a total of 8 cars and trucks in his toy box. His 5th birthday is soon, and he hopes to double the number of cars he has now so that he will have 11 cars and trucks total. How many cars does he have now? Create and use a system of equations to solve. So the first step when you're doing these word problems is you want to first state what your unknowns or what your variables are. So in this case, Christian wants to know how many cars he has and how many trucks. So we're going to say that C is going to represent the number of cars. And we'll say that T is going to represent the number of trucks. And once you have established what your variables are, then you can start to create your system of equations. So let's look at the information we have. Right away it says Christian has a total of 8 cars and trucks in his toy box. So we know that C plus T is equal to 8. Okay, what about the second piece of information? 5th birthday, that doesn't tell us anything. He hopes to double the number of cars he has so that he will have 11 cars and trucks total. So instead of just C cars, he wants 2C, right? So double the cars. The trucks stay the same. And in total, he's going to have 11. Right, so now we have our system of equations, and now we can solve just like we normally would before. Right, we have our 2 equations and our 2 unknowns. So I'm not going to spend too much time going through how to solve this, but if you were to go and solve this, it solves pretty easily using elimination. So you get 3 cars and five trucks, right? That's how much he started out with initially. Right, the one thing I will highlight, right, make sure you include units. Right, so because it's very important. What is it? 3 what? It could be 3 anything, right? You need to indicate that it's 3 cars and 5 trucks. Okay, let's just have a look at one more. So this one is a little trickier. So this one, it says, Sophia needs to make 10 liters of 42% sulfuric acid solution. In the supply, she finds bottles of 30% sulfuric acid solution and 60% sulfuric acid. What volume of each solution should she mix in order to make the 42% solution? Right. So she wants 10 liters of 42% sulfuric acid solution, but she's only got bottles that contain a concentration of 30% and 60%. So we need to mix the two in order to get 10 liters of a solution that has 42% sulfuric acid. So first, we need to establish what our variables are. Just going to call them x and y in this case. So for x, we have, right, it's the number of liters of 30% of the sulfuric acid solution. Right, we need to figure out how much of each of those we're going to use, right? So we need to know the number of liters of the 30% solution and also the number of liters of the 60% sulfuric acid solution. So those are our two variables. That's what we want to try and figure out. So now we look at our information and how can we create equations? Well, we know that we need 10 liters altogether. So our x plus y is going to equal 10. And our second equation, so we need for those 10 liters to give us a 42% concentration. So we know that x is the 30% solution. So for every liter that we add of x, it's 0.3. And we know for every liter of y that we add is 0.6. So 0.3x plus 0.6y has to equal, right? Well, we have 10 liters altogether. And we know that the solution, let me rewrite it the other way just so it stays in the proper order. So we were writing our concentrations first. So we know the concentration has to be 0.42. And we know that we're going to have 10 liters altogether. So I'm just going to rewrite this second equation here. 0.3x plus 0.6y is now going to be equal to, I'm just going to multiply these two together because those are just two numbers, right? There's no variable there. Put a 4.20. All right, so we've got one equation here and another equation here. We have our two equations and we have our two unknowns. And now we can proceed like we normally would in any of the other questions that we've done. So I'm just going to write out a solution here, and you should be able to follow along. I used substitution when I solved this. All right, so if we look at our solution, we have that we will need 6 liters of the 30% solution, and we'll need 4 liters of the 60% solution. And we can think about it, does that make sense? Well, 42% is closer to 30%, so it does make sense that we're going to need more of the 30% solution than the 60% solution.